I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Exoplanets, which orbit stars outside of our solar system, are so distant they're hidden from our view. And light from their so-called parent stars makes them nearly impossible to see. But a twist on an existing device could change that. Researchers at the University of Arizona have designed a coronagraph, optical technology that blocks direct light from a star, making nearby objects visible, that draws starlight away from exoplanet light before capturing an image of it. Directly viewing and studying exoplanets with conventional telescopes has long been a challenge, given the close proximity to their much brighter parent stars. The new coronagraph design uses a spatial mode sorter to isolate and eliminate light from a star. Once that light is removed, an inverse mode sorter can then recompose the optical field to directly capture images of only the exoplanet. In testing their device on an artificial model, the researchers found they could estimate an exoplanet's position at subdiffraction planet-star separations. The team says their coronagraph design could potentially detect biosignatures and maybe even the presence of life beyond our galaxy. Thanks to $17 million in seed funding, a novel color-splitting technology is now in the works at sensor developer eyeo, a Netherlands-based spin-off of imec. The investment, co-led by imec Expand and Invest NL, will help eyeo further advance its single-photon guiding technology the company says breaks resolution limits. Notably, rather than filtering photons, the technology directly hits individual pixels to allow full light sensitivity and natural color fidelity. Company representatives say this recently awarded seed funding will help enhance their existing camera sensor designs, optimize their waveguide technology for production scalability, and accelerate prototype development. In other business funding news, Tau Systems, a Texas-based developer of compact laser plasma accelerators, will receive an additional $20 million in seed funding, extending its total so far to $35 million. This new investment, led by Quanta Nation, will allow the company in part to establish the first privately owned and operated laser particle accelerator in California. With sights set on the future and ultimately the health of our planet, scientists and engineers in Germany are working on a new generation of high-precision optics that can withstand the extreme condition in a laser fusion power plant. Highly reflective and thermally stable mirror systems will be essential components for such facilities that aim to put carbon-free energy on power grids potentially within the next decade. Designs continue to evolve, but researchers say a commercial laser-driven fusion power plant featuring 400 beam lines will require around 7,000 optical components, including about 3,200 reflective mirror optics that will elevate the efficiency and effectiveness of fusion experiments. Germany's new Scalable High-Power Reflectors for Petawatts Consortium, or SHARP, is now working toward that, with a primary focus on thermal stabilization and active conditioning. In particular, a team from the Fraunhofer Institute of Applied Optics and Precision Engineering IOF, among a collaborative group of researchers working under the consortium, is now developing techniques including for the scientific and technical foundations of substrate manufacturing for high-performance mirrors and characterization methods for thermally stable and laser-resistant reflectors. The IOF team says they're now delving into the initial phases of technology development to ultimately scale up large-area optics. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.